Okay, and we are back with example number 3. We're going to talk about end behavior of graphs of functions. The end behavior is the behavior of a graph as x approaches positive or negative infinity. As you move right along the graph, the values of x are increasing towards infinity. This is denoted as x approaches infinity. Okay? So this arrow sign means approach. At the left end, the values of x are decreasing toward negative infinity, denoted as x approaches negative infinity. When a function f of x increases without bound, it is denoted as f of x approaches infinity. When a function f of x decreases without bound, it is denoted as the function of x approaches negative infinity. Okay, so we're going to describe the end behavior of each linear function. So as x decreases, that means as x goes to the left, what's happening to our function? It is increasing. F of x increases as x increases. As x decreases, f of x increases. As x increases, so as x is getting bigger, what's happening to our function? Our function is going down. It decreases. Thus, as x approaches negative infinity, so as we're going this way, our function is going to infinity. Let's see if I can make the infinity sign here. Maybe if I just write it in. Infinity. As x approaches infinity, so as it's going this way, what's happening to our function? Our function is going to negative infinity. Negative infinity. All right, let's take a look at g of x. What's going on over here? As x decreases, so as x is going to the left, or increases, going to the right, g of x is always 2, or g of x equals 2. Thus, as x approaches negative infinity, as we're going this way, g of x is going to equal, well, no matter what, our value is going to be 2. Let's just type in 2. And as x approaches infinity, again, our function is still going to stay at this level, which is 2. And I think I'm going to let you guys go ahead and do those on your own. Let's look at example 4. Describe the end behavior of each nonlinear function. So as you move left or right on the graph, what is f of x doing? Just take a moment to think about that. I'll get back to you in a second. Okay, sorry about the confusion. I'm not really liking too much how they phrase this question, because it says as you move left or right on the graph, what's f of x doing? Well, if you're moving this way, if you start here and you move to the right, it's decreasing. But what they were talking about is if you start, sorry, I'm here pointing and you guys can't even see it. But if you start here and you move to the right, you're actually going down, right? Correct? Or if you start over here and you go left, it's actually decreasing. But what they're talking about is if you start right here, right at the minimum, and you go left or you go right, in both cases, it is increasing. So we're going to write increases. Thus, as x approaches negative infinity, so as x is going to negative infinity, what's happening to our function? It's approaching infinity. As x approaches infinity, so as it's going this way, what's our function doing? It's increasing up, so it's going to be positive infinity or just infinity. All right, let's take a look at g of x over here. As x approaches negative infinity, what's happening here? Our function is going down, so it would be negative infinity. I'm just going to put minus infinity. As x approaches infinity, so as x is going this way, our function is going up and up and up. So this would be, what do you guys think? Negative infinity or infinity? We're going upwards, it will be infinity. And that concludes, actually, you know what? Let's go for it. Let's do example number 5. Okay, here is example number 5. Determine and interpret in behavior. So we're talking about drones here. The graph shows the altitude of a drone above the ground f of x after x minutes. Describe the in behavior of f of x and interpret it in the context of the situation. So I'm looking over here, and we have the time in minutes. So after 1 minute, it reaches at about 80 feet. Okay, this is our altitude, how many feet above the ground we are. So it kind of looks like it's going up and stay, and then at this point, after 2 minutes, it starts to go down a little bit. We call this a relative maxima. And then when we come down here, this is a relative minima. And so anyways, it's flying this way. Since the drone cannot travel for a negative amount of time, the function is not defined for x is less than. So we can't go back in time. We can't go minus 1 minute. So right here, x cannot be less than 0. So there is no end behavior as x approaches. What do you guys think? As x approaches negative infinity, right? There's nothing over here. So we'll put negative infinity. As x approaches infinity, so as x is going this way, what's the function doing? It ends off right here with an arrow going up. And this is not negative infinity, but it is infinity. The drone is expected to continue to fly higher. Okay, so it's going to just keep going up. And let's go ahead and do this one last problem. Ride sharing. Mika and her friends are using a ride sharing service to take them to a concert. The function models the cost of the ride f of x after x miles. Describe the in behavior of f of x and interpret it in the context of the situation. So obviously, the more miles you go, the more it's going to cost. What is the end behavior of the function? So as x approaches infinity, what's happening to our function? Our function is also approaching infinity. So let's see if we can find that. That's no good. That's not what we want. We want x approaches infinity. So that's not it. That's not it. It's got to be one of these two. Is our function going to negative infinity? Nope, can't be that one. It's got to be this one here, letter D. And that's it for example number 5. That concludes our lesson 1-3, and we'll see you next time. Happy studying.